Great. Thank you so much for coming and talking to us here today. I thought I'd just introduce you shortly while Fredrik helps you set up your presentation. Aurimas is the acting lead of data and analytics domain at SEBx, which is a part of SEB, the bank. So it's going to be really interesting to hear about how you approach some of the kind of same problems we have actually in healthcare about trying to predict outcomes and the way you approach that in your industry. So with that said, welcome Aurimas, and it's really nice to have you here.
Thank you. Thank you very much. So right now, probably I'm gonna share my screen.
Yes, you should be able now to do that. Yeah, there you go.
Okay, and I guess you can see it now, can't you?
Mm-hmm. Yeah, you can see.
Yes.
Okay, so thank you very much for a very nice introduction, and thank you for having me in here, and I really appreciate, you know, for having some time to talk in here about what kind of issues, challenges we have, and our achievements a little bit. So as you mentioned, my name is Aurimas, and I am working in SEBx, and today I would like to tell you a little bit about the PD modeling using big data and machine learning algorithms. And I don't know if you know, but the PDs in banking world stands for probability of default, or, you know, probability of a customer not being able to fulfill the obligations and pay back the loan, basically. And, you know, just to manage the time in a better way, I would kindly ask you, you know, to leave the questions for the end, and then, you know, I will be more than happy to have a discussion about it. And if we go further a little bit, the first to the structure of the presentation, the first thing, you know, we'll go through a little bit of introduction, who we are and what are we actually talking about here, and a little bit, you know, since at the end still it is a model we're talking about, so I will tell you a little bit about the development process of it, you know, what were the steps and what kind of the data was included in it, because, you know, without the data no model could exist. And then we'll go a little bit into more details when it comes to how these features or explanatory variables were generated, then how they were combined together, and, you know, we managed to get the result of a PD in the modeling phase. And then at the end, last but not least, is of course, you know, some conclusions where I will try to break down some advantages and disadvantages of the process as well as of a model we actually, you know, ended up with. And I'm really sorry about the way how I present the slides, because I don't have an Acrobat reader on this computer, so it looks weird. So sorry about that. So when it comes to the background information, so yes, we are SEBx, and as the name suggests, you can probably figure out that yes, we are part of SEB, and as I call SEBx is an initiative of a bank within the bank. But basically what we are trying to do in SEBx, we are trying to explore the new technologies, the new, you know, products, customer segments, and many things like this, in order to keep up, you know, with the industry which is being revolutionized by all the fintechs that we have. So this is, you know, SEBx is the place where SEB is trying out new things and technologies, and, you know, trying to keep up the pace, basically. And in order, you know, to test out these technologies, the first thing and the first segment that we actually chose to work with is solopreneur. And the solopreneur actually stands for solo entrepreneur. So basically, you know, people who are working on their own, who are handling their finances on their own. So, you know, it can be anybody from hairdressers, taxi drivers, programmers, consultants. But, you know, the most important feature of them is that they are actually on their own and doing finances, bookkeeping, accounting, you know, maybe with the help from somebody, but still it is them as a very small companies, let's call them like this. So this is our first customer segment, and since the product that we started to offer them, of course, we're still in beta phase where we are testing the product, but since this product is something that has, you know, a credit component in it, that's why we had to take care of the credit scoring, or, you know, the credit risk assessment, which is this probability of default estimation, where we need, you know, to know what is the credit worthiness of the customer. So that's why I came into place, because I'm actually coming from the credit risk world, and in SEBx we tried to handle it. And actually during, you know, today's talk, I will tell you a lot about the third-party software that we used as a way to explore new tools and technologies in SEBx. So basically we were in partnership with one company that is providing a very powerful tool for modeling and feature generation. And this is what we actually did. It doesn't say anywhere on the slides here, but actually this tool and company is called Spark Beyond. It is an Israeli startup, and they actually focus on feature generation and actually, you know, combining those into model to making good predictions and things like this. And at the time, it was actually, I think, almost 2 years ago, at the time when we had to build the model, we had no customers in SEBx at all. It was basically, you know, data was not existing. So that's why, you know, we were kind of leveraged a little bit from SEB, where we selected the sample similar to the solopreneurs. And this was the data that we actually used to train the model and, you know, to finalize it. And one of the other reasons why we are actually trying out these new technologies and new ways is that it's not only, you know, the banking industry itself going forward. So it's also, you know, the modeling algorithms, the modeling techniques, the machines that we are using to estimate and to train the models are improving. So that's why we also want to go forward and to finally challenge this simple logistic regression, which is irreplaceable in the banking world from, you know, from the regulator's point of view, or from everybody, you know, who is working there. So that's why we wanted to revolutionize it a little bit from that point of view as well. And they tried to use something from the machine learning world. Then if we talk a little bit about the data process, and not the data, but the development process, it is an extremely regular development process of, you know, any kind of model that you build. At first, we have collected the data. Then we did this EDA analysis, exploratory data analysis, because we had, you know, to clean it up and to make it ready, because there is no such thing as perfect data quality anywhere. So that's why we kind of needed to prepare it a little bit. Then, of course, we did these regular steps. At first, the single factor analysis or feature generation, where we look for what could explain the potential, the PD or the probability of default. And then in the next step, we actually combine them together and try to get, you know, the model where all of these features or explanatory variables are grouped together or put in a formula, so to say, to get, you know, the final result of a PD value. And after each and every iteration, because there was not one iteration, you know, with a different set of features, different number of features, etc. At the end of each iteration, we were doing the testing of the model, and this was performed by, you know, taking from the data. We split it into 3 parts: train, test, and validation sets, where test is the out of sample and the validation is out of time. Samples, you know, just to try out whether it really works and that the overfitting is not an issue in there. And when it comes to the data structure, I would say, again, it is something, if you have ever seen, you know, anything in the PD world, it's usually, you know, that we have the loan data, which can be the loan amount, the loan, you know, maturity, or things like this. And the default flag is also a part here, because when it comes to the small customers, it is possible to model them not on the customer level, but on the arrangement, on a loan level, so to say. Then we also have the customer information, which can be anything, you know, from income to financial statements, as we are talking about these very small companies. And then we also have, which is something new, I would say, which is this transaction information. And this is where the big data word comes into play. Because this transaction information, you know, you can imagine that how many customers are making transactions, because, you know, each and every customer might have a debit card, a credit card, or whatever. And, you know, we have loads and loads and loads, you know, of this kind of data. So this is actually the exercise. We tried to employ this data and actually use it. And we also have the external data, and this is actually something I will tell you a bit more about later. But we actually managed, with the help of this third-party tool, we managed to employ and test the OSM OpenStreetMap data, which is basically, you know, a map, online map, where you can go in and you can modify it by yourself. And based on the coordinates we see in the historical data, we were able, you know, to look for some features, and we will see that sometimes, you know, they can be quite funny. And as the color suggests here, it was not used at the final version of the model, but still, just, you know, just for having fun purposes, I will tell you a little bit about them. And when it comes to this third-party software in the development process, it was very good for us because it was easy to handle the data. Because, for example, we didn't have to join the loan data and the customer data in advance, meaning that, you know, one customer can have several loans. So we would need to make the table even bigger. So we didn't have to do that. And by providing the keys, we were able to do that in the platform, in this third-party tool. Then this tool, as it specializes in this, you know, feature generation, it explores millions of features by taking, you know, one column and going through all different kind of thresholds and then selecting which one is the best. And last but not least is the easy implementation. It is not something, you know, extremely interesting from the modeling point of view, but for us it was a very good thing, because usually this type of exercise takes a lot of time and is extremely burdensome. So that's why this was also, you know, an advantage for us when it comes to exploring it. Then, if we talk about the feature generation itself, I would separate the features into two categories. We are talking about the regular features, and these features, you know, are the ones that are constructed using the regular loan and customer data by taking, you know, the level of income, the level of savings, the level, you know, of everything that is usually used in the credit risk models. And then these features are generated by looking at these different thresholds, doing this text mining. You know, if we have string fields, then the platform is looking for some specific patterns, like, you know, if this is replicated a lot in the data, then, you know, it might show one or the other thing. And then last but not least is, of course, we can, by choosing the different complexity in the platform, we can select, you know, the way how these features are constructed, and several columns can be grouped together, basically, in order to get one or the other feature. So this is when it comes to the regular ones. But when we're talking about the transaction information, the question is, how should we construct something out of it? Because let's say we need to estimate the PD value at end of 2020, and then, you know, the customer is making millions of transactions. So what do? We take the last month, the last 2 months, 1 year. Do we take the sum of transactions, the average of transactions, the minimum? You know, there are plenty of different things to consider. So that's where it becomes extremely difficult to handle this kind of data. So that's why, you know, this platform is extremely helpful, because there is this time series concept taken into account, where we have, you know, this moment of the observation when we are interested in this estimating this PD value. Then we select the period of how long we want to look, you know, for something. And then what this platform does, it takes, you know, this time period, and then in the time period looks for many different features, and then, you know, it can be related to how these transactions behave over time, whether, you know, the amounts are increasing, decreasing, what is the average, what is the minimum, maximum. You know, it explores all of these different possibilities, and then answers, you know, the question whether it is worth it to include something like this or not. And of course, you know, the same approaches are applied. Like if we have a transaction information like date, amount, description, then we can do, you know, many different things related to amounts. And with the descriptions, because, you know, this text mining can be definitely applied in there. And as soon as we have the features and they are constructed in the platform, we need to know, you know, which one is the best one, which one is the worst one. So this is where this relative information game comes into play, and we rank order them based on this value. And at the later stage, we can, you know, based on it, we have a top 100, top 150, or top 50, and we decide where is the cutoff, how many of these features are actually included in the later stage, where we actually try to estimate and train the model. Then, if we are talking about, you know, what kind of features are actually generated, just to be fair, I am not disclosing, you know, the actual details, like if the outstanding amount is higher than this, then we have something. I'm not disclosing things like this, you know, because of this bank secrecy, so to say. But in general, you know, we can go through what kind of the features we have and what kind of the features we get. So when it comes to the regular features, I would say that it's completely nothing new. It is definitely something that we have seen before. So, you know, one of the strongest features are usually related to credit history, you know, whether the customer was late in the past on one or the other, you know, scheduled payment. Then there are many features related to the profitability. When we compare income versus expenses, either, you know, from the private side or from the company side, because we are taking into account this, you know, these small companies. Then we are talking about the solvency, savings amount, equity amount, you know, wherever you take it from the financial point of view. And of course, liquidity is also always a thing, you know, to consider. But if we talk about the transaction features, these are much more interesting. And these features usually relate to some specific transactions. For example, in the transaction description, we see a company which this transaction goes to. And then, you know, if there are many transactions within that period of time we have selected in the last, you know, 3 months, 4 months, 6 months, then we see that, you know, it helps to explain the higher probability of default. Sometimes it is related to the dynamics of the transactions, and one of the features that I really like is this: if the standard deviation in the period we have selected of transactions is going down, meaning that the customer is spending less and earning less, then we see that there are some kind of problems and probability of default is going up. Then we also have the type of transactions, and this is usually related to these. When it comes to transactions, we have these verification codes, and this verification code, it is a 10-digit code, and based on what kind of digits we have, we can identify, you know, the bank this transaction is going to, or the industry this transaction is going to. So this, we also get plenty of features related to these ones as well. And what is interesting when it comes to transactional features is that we have, like I said, you know, just a few fields. And then out of these few fields, we construct many features, like transaction amount. You know, if there is a transaction higher than, let's say, 10,000, it is one feature. If the average transactions, you know, is higher than something, it is another feature. And then we can create many of those. And this, you know, this is where this, even though it's only a few features, but since we have, you know, loads of data, we can actually employ it in a very good way. And then, as I said before, we have these funny features, the ones that are coming from this OpenStreetMap data. And here we found things like, you know, if the customer is living close to Thai restaurant, the probability of default is higher. If the customer is living close to Japanese restaurant, is lower. You know, so things like this, like churches, stations, prisons, golf courses. Of course, in some cases, especially when it comes to the golf courses, we can think of, you know, if there is a golf course, then it's probably some kind of a fancy neighborhood and people with, you know, higher income living there. So there might be some reasonable explanations, but since it is extremely impossible to justify, you know, for somebody that you're not getting a loan because you live close to one or the other type of restaurant. So that's why, you know, we kind of thought, no, maybe let's not take it into account. And, you know, it's the data quality can be questionable. So that's why we decided not to use it. But it was extremely fun to test it around and you know, see what is happening and what kind of outputs do we actually get. Then, if we talk a little bit about the modeling, so now we have the features generated, you know, we are covering these different parts, starting from loan data, customer data, and transactional data, and then we're trying to combine them together. And what we actually did there, it was that in this platform I'm constantly talking about, we have this possibility to select a list of algorithms that are actually used to train the model. And we have, you know, tested plenty of those, including logistic regression classifier, decision tree, random forest, XGBoost, and spoiler alert, XGBoost was the best one. This worked the best, comparing, you know, everything, the AUC values, and how stable the result is when we, you know, take the model and estimate the parameters on the different samples, like, you know, this train, like this test and validation. And what we actually did, you know, we tried these different algorithms, and then by selecting different number of features, we have actually decided, you know, what is the right amount of features for us to use. So, you know, the result is most stable, the predictions are still very good, etc. So this is how, you know, we ended up with a final model. And this final model, I would say, is that we had very high area under the curve values, and they were usually 15 to 20% better compared to the ones that we have using logistic regression. And it's this number, it's an interval, and it's not only one number, because the portfolio that we have covered, it covers several products. So our product is something completely new. So that's why we also had to select, you know, different products. And in the bank, the models are created, you know, one model for that product, one model for that, one for that. But in our case, we combine them together because our product is something new and something fancy compared, you know, to the old ones we have. Then we also got, you know, the stable values for different sets. And last but not least, we got a very nice behavior when it comes, you know, to looking at these PD and observed default frequency numbers across the pools. And you can see that in the picture right here. We have split, you know, the portfolio into these different pools. And you can see that the red line is observed default frequency, and the black line is the average PD value, and they behave very nicely. They are increasing over time, and they go, you know, along one another. And if we come a little bit to the conclusions part, first of all, if we talk about the advantages, so first of all, when it comes to this third-party software, for us it was extremely easy to implement the model afterwards. We actually built it. Then it was very easy to handle the data. You know, we just basically uploaded it to the platform, and then, you know, we didn't have to worry that much about joining it and, you know, doing some other kinds of stuff. Then it was finally, you know, the time when we managed to incorporate the big data, which is the transaction data in our case. Of course, we have saved, plenty of time for feature generation because we didn't have to go into this transaction information and try to look for one or the other ways to how to aggregate it. We definitely have, significantly improved predictive and discriminatory power. No matter how you look at it, because on these bucket levels, we see that the PD is in line with the ODF, and the ranking is very good, which is proved by this high AUC values. Then we also have stable validation testing outcomes, and it says here that the multicollinearity problem is non-existent. It's not like it's non-existent, but we basically didn't care about it because, when we employ machine learning algorithms, this assumption of independence, when it comes, to explanatory variables, we can actually get rid of it, but it creates another problem, which is this lack of explainability, because usually in the logistic regression, if everything else is constant, then you can easily explain, the effect of one or the other variable, which is extremely good, and regulators are extremely happy about that. But of course, as we are moving forward, if we have these fancy and very well working algorithms, why not to try and use them in one way or another? Then another potential disadvantage, I would say, is this risk of misusage. And here I am specifically referring to, these requirements when it comes to ethical matters. For example, in our model, we definitely don't have things like gender or, something like this taken into account. But what if this, is somehow identified in the transactional behavior? And what if this, indirectly, but is included in the model? And actually, from the regulatory point of view, there are many discussions going around that when it comes to this explainability and this potential misusage of the model. But still, we have tested based on these different, sensitive categories that there is no clear difference. So that's why we kind of feel that we are safe. But still, when it comes to a model like this, it is a potential risk. Then another thing is that it is difficult to assess the significance of variables because, like I mentioned before, we had the features rank ordered based on this relative information game. And the question is, where is the cutoff, where we have all of the significant variables and the ones that, that start to be insignificant. So we don't know that. That's why we were testing different number of features. And then the one that we liked the most was selected as the final one. And in comparison in logistic regression, we can always have the t-test as a significance of the variable. And then we can say that, it was significant or not. Then we need to make more assumptions, and this is the specific assumption I have in mind here is this window for how long back we are looking in the transaction information. And so because it is not, selected anyhow scientifically, we need to think about it. What is the reasonable period of time we take into account, and that's how we select it. And last but not least, when it comes to the disadvantages, is this lag of regulation. Because right now, for example, yes, we have created a model like this in SEBx, but right now we are not intending to use it for regulatory matters. And when I say regulatory matters, I mean the calculation of capital requirement, stating whether we are solvent enough. Because at this point in time, I would say that the regulators would definitely not approve it because of this lack of explainability. And another thing is that when we talk about the machine learning models, we usually think about it as something that we retrain when we get additional data. But from the regulatory point of view, you create a model, you go for approval, you get approval, and then if you want to change it, you need another approval. And just to be on the safe side, the process it takes 1 year. Is it something that we can afford, using real-time data? Probably not. So as soon as the regulation, catches up, then it's going to be easier for us. So I think this is it from my side, and I think right now I would be more than happy to take as many questions as possible.
Great. Thank you so much, Aurimas. This was really, really interesting. I saw already now from the chat that we have a question from Eric, so I thought we'd jump right in.
I have a question regarding using the customer's data. I understand that you use data from transactions, so where you bought stuff, when and how much, blah, blah, blah. So that's a lot of information from individuals. Is there some kind of ethical review board or something that every sort of research project have to go through, in the same way that when we use patient data, we have to get approval?
Well, actually, when it comes to this, I would say it's easier for us. And it's easier for us because we have this, I don't remember exactly how it's called, but there is this regulation that, you know, defines that you need to do this credit scoring and assess the risk of the customer. And in order to assess the risk, you need to use the information like this. So that's why, you know, we are kind of it's legally okay for us to use this information because we have to use it. So from that point of view, it's much easier for us.
Great. Do we have any other questions from the audience? I thought maybe I can have a question. I thought this was really interesting, and I think there's so many parallels to the discussions that are going around in the healthcare industry now as well. We're you know, talking a lot about the explainability issue. You know, regulators in Sweden are now discussing, can we have these, you know, scores or models that are sort of black boxes without explainability, or even proprietary, where we're not even allowed to know what factors are being assessed? You know, should we allow those? How should we, you know, work with those, especially when it comes to people's health and so forth? So I think we're almost in parallel, the finance industry and the healthcare industry, because we're sort of both tackling these issues at the same time. And of course, the regulatory aspects are perhaps slightly different. Like you mentioned, you have to do it, whereas we have to control the quality of healthcare as well, but we're not required, at least as of now, to use data in this way to do that. But it would be really interesting. Perhaps you could give a hint to us in the healthcare industry, sort of what are the things you're really looking forward to in the finance industry when it comes to these kinds of PD models, and what are some things you're sort of concerned about?
Well, first of all, what are we looking forward to is definitely, you know, regulators getting used to models like this. So as soon as, you know, we have regulators that are used to this, then, you know, we are likely to get the approvals for models like this, and, you know, we can actually start working with them, you know, from a broader point of view in the whole bank, so to say, not only, you know, in this sandbox SEBx as we have it right now. And when it comes to the challenges, this explainability thing is definitely also a challenge for us, because right now we are testing this explainability. You know, for example, if we have one or the other continuous variable, then, you know, we are taking each and every possible value and then calculating conditional averages and get some kind of, you know, feeling how this or one or the other variable is affecting the PD value. But still, when it comes to, you know, saying to the customer that you are not approved because, you know, your let's say, you know, your income is too low, but this is only, you know, from this conditional analysis. Are we really sure that this is because of that? I would say that this is the biggest challenge when it comes to be extremely transparent with the customer and, you know, saying the reasons why he or she is not onboarded.
So a follow up to that, that's really interesting. So the way we sort of think about that in healthcare, I think, is once we create these kind of scores or models where we try to predict a particular outcome, the healthcare provider, the nurse or the physician always has that sort of last veto where it's like, oh, this is totally unreasonable, or this model doesn't make sense in this case, or my gut feeling says something else, even though this model says this. Is that how it works in the finance industry as well? Do you have sort of have a teller veto like that? Okay.
Yes, exactly. Because right now, we always have this automated onboarding process. It is, introduced from time to time. But for example, right now in SEBx, what we do, we use the model, we get the score, we get the PD value, but still at the end of the day, we have this expert or credit advisor or client executive or whatever we call that. We have who at the end approves or disapproves the customer. But this is, I would say the process where we are going to and, looking forward to actually making it as much automated as possible. So right now we can say that we are testing this model from that point of view. We still have this veto. And, if after a while they say, yes, the model is working perfectly, let's go live with it, to an automated decisions. So right now we are testing it not only, from the product perspective, how it works, but the model is also being tested by having this veto, as you say, at the end. But the thing that I'm definitely looking forward to is complete automation and, not having that at the end.
Great. Thank you so much. This was an extremely interesting talk, and it was really interesting to hear about the ways that you tackle these kinds of issues in your industry. Before we go, are there any last questions from the audience? All right. Well, thank you so much, Aurimas. This was really interesting, and I think in particular for me, the sort of parallel problems that we have in both of our industries, and especially when it comes to it being, in the healthcare, we're talking about people's health and people's lives, but in finance, you're also talking about people's livelihoods and people's access to financial markets, and both are, extremely important to people's well-being and quality of life. So I think it's going to be really interesting to see how each industry deals with these problems and continuously see if there are things we can learn from each other.
Exactly. Thank you once again for having me. It was really nice to speak in